It has been one day and the 2026 Advanced Higher Maths paper is already out. So I'm going to complete it again and show you what I did and my thought process while doing it. After the exam, I thought paper 1 was really easy and I thought paper 2 was a lot more challenging. And at the time, I believed I had gotten full marks in the first paper. But at the end of this video, I'll mark the paper and see what I actually got. So let's get started. So the first question says, differentiate y is equal to 3x to the power 4 sec 2x. And from the formula sheet, we can see that sec x is equal to sec x tan x if you differentiate it. So using product rule, you can put 3x to the power 4 and sec 2x. Bring the power down to make that 12x to the power 3, and sec 2x should differentiate to 2 sec 2x tan 2x. So that means u dashed v plus u v dashed. 12x to the power 3 times sec 2x plus 3x to the power 4 times 2 sec 2x tan 2x. And I'm pretty sure you can just leave it like that. I think what I did was I just put them in brackets, and you can times 3 and 2 to make 6x to the power 4 sec 2x tan 2x. And yeah, hopefully that is the answer. So now part B says differentiate e to the power 5x over 2x plus 1. So again, you've got your u is e to the power of 5x. U dashed is equal to 5e to the power of 5x. V is equal to 2x plus 1, and v dashed is equal to 2. So using the quotient rule, you've got u dashed v minus u v dashed over v squared. 5e 5x times 2x plus 1 minus e to the 5x times 2 over 2x plus 1 squared. And if you multiply these out, you've got 10xe to the power of 5x plus 5e 5x minus 2e 5x over 2x plus 1 squared. And now you can do 5e to the power of 5x minus 2e to the power of 5x. So that gives you 10xe to the power of 5x plus 3e 5 to the power of 5x over 2x plus 1 squared. And that should be the answer to part B. Right, so question 2 is a Gaussian elimination question. 1, 1, minus 1, 9, 2, minus 1, 3, minus 2, 3, 2, minus 2. Right, and 21. So I've set it up like this, and now you can do row 2 minus 2 row 1, and row 3 minus 3 row 1. So the top row stays the same, 9, and that's 2, that comes 0, so then that becomes minus 3, and this becomes 5. Minus 2 times 9, minus 18, that becomes minus 20. Row 3 minus 3 row 1, so that becomes 0. 3, so that becomes minus 1. So that's minus 2 plus 3, so that's just 1. So that's 27, so that is just minus 6. So now you can do 3 of row 3's minus row 2. 1, 1 minus 1. 0 minus 3, 5 minus 20. So this becomes 0. This becomes 0, and 3 times 1 is equal to 3. 3 minus 5 is minus 2. 3 times minus 6 is minus 18. minus 18 plus 20 is minus 2. Nope, that would just be normal 2. So now I can find my x, y, and z. So z minus 2z is equal to 2, which means z is equal to minus 1. Minus 3y plus 5z is equal to minus 20. Minus 3y plus minus 5 is equal to minus 20. Minus 3y is equal to minus 15. So that means y is equal to 5. And then x plus y minus z is equal to 9. Z plus 5 plus 1 is equal to 9. Z is equal to 3. Sorry, x is equal to 3. So if I just write this out neatly, so these should be my x, y, and z. Right, so question 3 says a complex number is defined by z is equal to the square root of 3 plus I. Express z in polar form. So if z is equal to root 3 plus I, we can find r. I forgot what this is called, but I know how to do it. So it's the square root of 3 squared plus 1 squared, which is the same as the square root of 4, which is 2. And next I need to plot z is equal to square root of 3 plus I on a graph, so 3 there, I, line there. And I know with my exact value triangle, if I draw this upside down, so that 30 is at the bottom, 60 is at the top, 2 root 3, 1, which is what we've got because it's root 3 this way and 1 this way. So that means that the angle is 30 degrees, which is the same as pi over 6. So writing it in polar form, I can say z is equal to 2 bracket cos pi over 6 plus I sine pi over 6. And that should be the answer. Okay, part B says use De Morgan's theorem to show that z cubed is purely imaginary. So De Morgan's theorem is on the formula sheet. So I can say that z to the power of 3 can be 2 to the power of 3 cos 3 times pi over 6 plus I sine 3 times pi over 6. So that means 8 bracket cos to the half plus I sine to the half. And if I draw out cos and sine, I can say that cos pi over 2 is 0 and I sine pi over 2 is 1. So if I write this again, 8, 0 plus 1, 1i, which is just the same as I, z cubed is equal to 8i, which is imaginary, hence statement is true. And this should be the answer for 3b. So on to question 4. Find the particular solution of the differential equation 2d squared y over dx squared minus 3 dy by dx plus y is equal to 0. So if we change this into 2m squared minus 3m plus 1 is equal to 0, we can solve to find m. So that would be what two numbers can add up to minus 3 and times to make 2. That would be minus 2 and minus 1. So if I do minus 2m squared minus 2m minus 1m plus 1 take a common factor of 2m, m minus 1 plus 1 brackets m minus 1. It's minus 1 here actually, instead of plus. Equal that to 0, so that means that 2m minus 1, m minus 1 is equal to 0. 2m is equal to 1, and m is equal to a half, and here m is equal to 1. So you can use these two numbers and put them into the auxiliary equation. Yc is equal to ae to the power of mx plus be to the power of mx. So you can plug those numbers in. Ae to the half x plus be x. So now we need to find a and b. So we've got values for y is equal to 2, dy by dx is equal to minus 1, and x is equal to 0. First I'm going to differentiate this. So this becomes a half a e to the power of a half x plus b ex. So now I can sub in the numbers. 2 is equal to a to the power a half times 0 plus b e to the 0, which is the same as a plus b, because e to the power of 0 is 1. And now plug in the numbers for the second equation. Minus 1 is equal to a half a e to the power of a half times 0 plus b e to the power of 0, which is minus 1 is equal to half a plus b. So now using simultaneous equations, I can say 2 is equal to a plus b, minus 1 is equal to half a plus b, and I can times the bottom equation by minus 2. So that gives me 2 is equal to minus a minus 2b. The a's cancel out, so that means 4 is equal to minus b, and that means b is equal to minus 4. So now I can sub that into 2 is equal to a plus b. 2 is equal to a minus 4, so that means a is equal to 6. So subbing those numbers into the original formula, y is equal to 6 e to the half x minus 4 e to the x, and that should be the answer. Okay, I'm going to move my camera over to this angle so you can get a better view. So question 5 says matrix A is defined by 3, 5 minus 2x. State an expression for the determinant of A in terms of x. So the determinant is A times D minus B times C. So that gives me 3x minus 5 times minus 2, which is 3x plus 10. And that should be the final answer. Part B says that matrix A is multiplied by matrix B such that det AB is equal to 12x plus 40. State the determinant of B. So now that I look at this, I think in the real exam I did make a mistake, so I did not get full marks. But let's try it now anyway. AB is equal to 12x plus 40. We already know that. The determinant of A is equal to 3x plus 10. So I think what I did was I just did det B was equal to 4x plus 4, and I'm not sure if that is correct. Okay, I'll leave it as it is now. Don't want to change what I've written in the final exam. But let's move on to part C. So part C says the inverse of matrix B is 1 minus 1 minus 5 over 4 and 3 over 2. Find matrix B. So the inverse of a matrix is 1 over the determinant, and then it is D minus B minus C A. If I find the determinant of this and plug it in here and also switch these around, I think I'll be able to find what matrix B is. So I'll write it somewhere else. Det B, well, we found out that det B was 4x plus 4, but I'm just going to use this. So 3 over 2 times 1 minus 1 times minus 5 over 4. So that is basically just 3 over 2 minus 5 over 4. So if I times this by 2, times this by 2, 6 over 2 minus 5, sorry, 6 over 4 minus 5 over 4 is equal to half. A quarter, sorry. So I remember in the exam I was able to figure out that x was equal to 0, but I can't remember how right now. Okay, so I figured it out. So if I just do 1 over 4, that is basically the same as 4. So that's the 4 bracket 3 over 2, 1, 5 over 4, 1. If I just times all 4 by all these, that gives me 4 times 3 over 2, which is 6. 4 times 5 over 4, which is 5. 4 times 1 is 4, and 4 times 1 is 4 again. So I think that should be the answer for B. So question 6a, use substitution u is equal to x minus 1 to find integral of x times x minus 1 to the power 4 dx. So u is equal to x minus 1. If you differentiate that, that gives you just 1. And if you times dx on the other side, du is just equal to dx. To find x, I'll just do u is equal to x plus 1, minus 1, sorry, add 1 to the other side. So that means x is equal to u plus 1. So integral of u plus 1, bracket u to the power 4 du. So I can multiply that out, and that gives me integral of u to the power 5 plus u to the power 4 du. And if we integrate that, that gives us 1 over 6u to the power of 6 plus 1 over 5u to the power of 5 plus c. And we can plug x minus 1 back in, so that would be 1 over 6 x minus 1 to the power of 6 plus 1 over 5 times x minus 1 to the power of 5 plus c. And that should be the answer there. So part B, hence find the exact volume of the solid formed by rotating the curve with equation. So part B says hence find the exact volume of the solid formed by rotating the curve with equation y is equal to 2 root x times x minus 1 squared about the x-axis through 2 pi radians from x equal to 0 and x equal to 1. So the formula for that is v is equal to pi times the integral of y squared dx. And the limits should be b and a. So now if you do v is equal to pi, so now if you sub in y, which is 2 square root of x times x minus 1 squared dx, and when you square root that that gives you 4x times x minus 1 to the power 4 dx, which is very similar to what we found in part A, x times x minus 1 to the power 4. So we can put 4 outside integral, so 4 pi, and we integrate x times x minus 1 to the power 4, which we can sub in as 1 over 6 times x minus 1 to the power 6 plus 1 over 5 times x minus 1 to the power 5, and our limits are 0 and 1. So now we just sub in our limits: 1 over 6, 1 minus 1 to the power 6 plus 1 over 5, 1 minus 1 to the power 5, minus 1 over 6, 0 minus 1 to the power 6 plus 1 over 5, 0 minus 1 to the power 5. So that gives us 4 pi times minus 1 minus 1 is equal to 0, so that all just equals 0. So then that's minus 1 over 6 times minus 1 to the power of 6 is just 1 to the power of 6. And minus 1 to the power of 5 is minus 1, so take away 1 over 5. So that's 4 pi minus 1, times minus 1 over 6 minus 1 over 5. I feel like I might not have got this in the exam, because I think I missed out one of the minuses, but it is only 1 mark probably. So now we can do 1 over 6 times, 1 over 6 minus 1 over 5 times 5 on one side times 6 on the other side. 5 over 30 minus 6 over 30. So it gives me minus 1 over 30. And actually, because that's a minus, this is a minus, so that means that it's actually minus 11 over 30. Okay, so V is equal to 4 pi times minus 11 over 30, which I definitely did not get in the exam. And that means that it is minus 44 pi over 30. And I can maybe simplify that. And actually, now that I think about it, I don't think V can be negative, so I've done something wrong again. Okay, I think because this is in a bracket, I think I need to do this separately. So 1 over 6 minus 1 over 5 times 5 times 5 times 6 times 6. 5 over 30 minus 6 over 30, which is 1 minus 1 over 30. Still don't remember doing this in the exam, but maybe I just made a big mistake somewhere. Now, because that's minus times minus 1 over 30, I can say that 4 pi times 1 over 30. I see my mistake now. I think in the exam I wrote 4 pi over 3 and I just missed out the 0, which is a really, really annoying mistake, which can be simplified to 2 pi over 15 units. So I think this is my answer. I definitely remember missing out this 0 because I wrote 4 pi over 3 in the final exam, which is pretty frustrating, to be honest. But we now move on to the final question. The complex number z is equal to 2 plus I is a root of the polynomial equation z to the power of 4 minus 2z to the power of 3 minus z squared plus 2z plus 10 is equal to 0. State a second root of the equation. So Second root would just be the conjugate, which is 2 minus I. That's our 1 mark. And for B, find the remaining roots. So you can make Z equal to 2 plus I. You can make that into Z minus 2 minus I. And you can make Z equal to 2 minus I. You can turn that into Z minus 2 plus I. And if you times these two together, Z squared minus 2Z plus IZ minus 2Z plus 4 minus 2I minus IZ minus 2I, so plus 2I minus I squared. You can cancel out the IZs and the 2I's. That gives us Z squared minus 4Z plus 4 minus I squared, so that's Z squared minus 4Z plus 5, because minus I squared is just 1. Okay, so now we can use this, Z squared minus 4Z plus 5. We can do long division. So Z squared can go into Z squared to make Z cubed. So we put Z squared at the top here and times each one by Z squared. So that's Z to the power 4 minus 4Z cubed plus 5Z squared. Take these all away, so that's 0. And that becomes plus 2Z to the power 3. And that becomes minus 6Z squared 2Z plus 10. To make 2Z cubed, we need 2Z times Z squared 2Z. And do the same thing, 2Z times each of these things, minus Z squared plus 10Z. So that gives 0 plus 2Z squared minus 8Z plus 10. And we need a 2 to make Z squared. So then you get 2Z squared minus 8Z plus 10. Take away all that, that gives you 0, 0, 0, which means that this contains the roots Z squared plus 2Z plus 2. And you'd need to use the quadratic formula. So minus b plus or minus square root of b squared minus 4ac over 2a. So that's minus 2 plus or minus the square root of 4 minus 4 times 1 times 2 over 2. Minus 2 plus or minus the square root of, so that's 4 minus 8, so that'd be minus 4 over 2. And that's the same as minus 2 plus or minus 2 to minus 1 over 2. And as we know, root minus 1 is equal to I, so minus 2 plus or minus 2I over 2, which is minus 1 plus or minus I. So the final answer of the remaining roots is Z is equal to minus 1 plus I. Z is equal to minus 1 minus I. And that's paper done. It was a pretty easy paper, but I'm still pretty annoyed that I got question 6b wrong. But now I'm going to mark the paper and tell you what I get. So I've just finished marking it, and the only question I lost a mark in when doing it now was for 5B, and I'd written that B was equal to 4x plus 4, which is just a really stupid mistake from me, because as you can see, if you just times 3x plus 10 by 4, you get that. So I don't know what I was doing in this and in the real exam, but everything else I got was correct. I'm still really annoyed about this. I think I would have maybe lost 1 or 2 marks. So overall, in the real exam, I must have only lost 2 or 3, hopefully it was just 2. So that means in this paper that I did now, I would have gotten 97%, and hopefully in the real paper I did, hopefully I would have gotten 84%, which I think is really good. That's actually the highest I've ever gotten in a paper 1 from all the other past papers I've ever done. But it also was a lot easier than the ones I've done previously. But paper 2 did kind of seem a lot harder. So I'll post a paper 2 video once the solutions come out. But yeah, overall very happy with my result, and I just hope that I still get an A, even though I didn't do as well in paper 2. But yeah, thank you very much for watching this video. If you enjoyed this, then please consider subscribing and giving this video a like. I'll soon upload the paper 2 version of this when the solutions come out, and I also want to do the higher National 5 paper just for fun and see if I've retained my knowledge in both of those. But yeah, hopefully you found this entertaining, and I'll see you in the next video.